RBS Basic Research Academy welcomes to you in the lecture number 43. In this lecture, we are understanding the repeated indicator approach and the extended repeated approach. Because when we apply the repeated indicator approach, some of the issues are arising in our model. So in order to solve these issues, the researchers, they have referred the repeated extended indicator approach. So in this video, we are going to understand the difference between the repeated extended indicator approach and the repeated indicator approach in the theoretical part of this video. And then in the practical part of this video, we will perform or we will apply these two approaches practically in our SmartPLS-4. I would like to remind you that this video is a part of my series on the higher order construct in the SmartPLS-4. So let's start our discussion. But before this one, my name is Dr. Rahim Sumro, and I belong to Shabati University, Pakistan, as a professor. So this is a certificate which was awarded to me from the SmartPLS Academy. Now, before going to understand the repeated extended indicator approach, it is very important to understand the higher order construct. So there are the four types of the higher order construct: reflective, formative, and the formative, reflective, and the formative and formative. So these are the three items of our first lower order construct. These are three items of the second lower order construct in such a way. So furthermore, if I want to understand the difference between the reflective and formative, we have to observe the arrow, the face of the arrow. The face of arrow is going from this LOC, lower order construct, to its item. So that's why it is called the reflective. This is also, now see, from the HOC it is going to the LOC. This is also a reflective. And then if you look here, here is our reflective. And then you're looking here, this arrow is coming from the LOC to its the high OC, HOC. So that's why it is called the reflective and the formative. So here they both are like these LOC and the HOC, both are the formative. And here these are the formative and this one is the reflective. Now if you want to know more the difference between the reflective and the formative construct, then these my two videos are available on my YouTube channel, and their images are you are looking here. So in order to understand the difference between the reflective and the formative construct clearly, specifying higher order constructs. So now how to specify higher construct? There are the two approaches are there: repeated indicator approach, and another is an extended repeated approach. Because when you are applying the repeated indicator approach, some of the issues are arising from this approach. In order to resolve these two problems, so the researchers, they have referred as the extended repeated approach. The two other approaches are there: embedded two-stage approach and disjoint indicator approach. Now what is a repeated indicator approach? Is simply, that means here what we are doing, that we are repeating repeated indicators are indicators of the lower order component. Now for example, these are our lower order components, and then what we are doing, that we are assigning these are the indicators of the all lower order construct to our higher order construct. So this is the simple job which we have to perform in the repeated indicator approach. For example, when the higher order construct consists of the three lower order components, this is our higher order component, in which consist of the three lower order components. So now we are assigning all these items to this one. This is the concept. And then in our example, now if data tangibility 1 to 3 items, empathy 1 to 4 items, responsiveness 1 to 5 items, reliability 1 to 3 items. So now what we're doing is that we are assigning all these items to its higher order construct. You are looking here. So this is our reflective, this one is our formative. Okay. Now you're looking, this tangibility is our first subdimension, empathy another subdimension, responsiveness another dimension, and the reliability is in another subdimension. So what we are doing, that we are taking all the indicators of all these three four dimension, and then all these are we are assigning to this HOC PSQ construct. You are looking here, all these items have been assigned uh, to the this higher order construct. The same thing is here. And then, so repeated indicator approach becomes problematic when reflective, formative higher order construct also serve as a dependent construct. So now with our reflective, formative, or formative, they become the dependent construct. So the problem arises. Problem. What if the problem arise? The problem arise that then when you are assigning all these, there is items to this one, then is the what will happen, that the components, that the this HOC will be fully explained, and that is the R square. There is the coefficient of determination will be 1. That means it has fully explained. For example, if we see the range of the R square, it starts from the 0 and ends at the 1. So that means that when our fully explained that our R square is 1. So that means there is no further room in the model to add another subdimension in the model, because already the model has been fully explained by the subdimension. So now you're looking here. Now this is the subdimension loyalty, and this is the subdimension quality, and these are their items. What I have done is I have assigned all these items to my lower order construct, and then you're looking here, by after assigning this, what will happen is the R square has become 1. HOC its R square has become 1. So now further there is no need to add any other subdimension to this R, because already these two dimensions have fully explained the model. Another issue, the first issue of the 100% R square will be 1. And another is that our direct effect will be insignificant, or our direct effect will be 0. So these two problems are arising from because of this one. Now you're looking here that our this direct effect of the certification on our LOC, HOC is a non-significant as well as it is a 0. Now, how to solve this problem? How to solve even these two problems? The Baker et al. Baker and his associate, they have suggested the another approach which is called the extended indicator approach. Now, alternative we call is a total effect analysis. So now what additionally we have to add the two other direct like the path from the antecedent construct to its lower order components. So now this is just we have to do this one in order to resolve these two issues of the like the direct effect has become insignificant, negligible, and then the R square has become 100%. So now in this way we can solve this problem. And then instead of analyzing the direct relationship between the antecedent construct and the higher order components, which is 0, that means here the direct effect is basically 0. Now we have to consider the total effect. Now total effect includes a direct effect plus indirect effect. When we add these two effects, it will become a direct, it will become a total effect. So in this case, this total effect also includes the indirect effect of the IDV, independent variable, on higher construct, while the lower order component portray an accurate picture of the antecedent construct total actual effect. Then the actual effect will be shown when you add the total effect, when you add the indirect and direct effect with each other. So now next one, total effect. Total effect means a direct effect and indirect effect. So now here in this case, which I already showed, our direct effect was 0, because the effect was negligible. 0, 0, it means that because of the R square was 100%. So now the indirect effect, the effect of the another independent variable direct effect, this was 0, because there was no room in the model to explain it. Already the R square has become 1%, 1. So that's why indirect effect was nil. So here, the first we have to take the direct effect XYZ on the HOC, and then we have to test the indirect effect XYZ through the ABC and on the HOC. So here you're looking at the total effect. Already our direct effect was nil or zero. So that's why we will consider the indirect effect. So now alternatively we can say that the indirect effect is actually our total effect. So now next, how we can perform these two approaches in the smart PLS. That is our practical part of this. I welcome you in the practical part of this video. Here you're looking one model where the four constructs are there: loyalty, quality, satisfaction, and behavioral intention. So first of all, we are applying the PLS-SEM algorithm to check the quality of these, the measurement of these, like the four constructs. So first of all, you're looking here that the R squared is quite good, 0.33. And then if we check their cost reliability, so except this the negligible error is there, otherwise that's okay. So now AV should be zero point 0.5 or higher, to just 0.02 or higher. So now if you wind off this, we can say this is a zero point 0.5. So almost 99%, there is no any problem. All are in the green color except this few ones. So now collectively we can call that we can say that the Cronpa alpha, composite reliability, and the AVE all are in the fine. So first of all, Davis, you should check all these things before applying any type of the like the approach or any type of the algorithm on your model. You should check all these ones. So now discriminability, HTMP, all are okay. So now and all things are okay. Now we are applying our extended indicator approach. But first of all, we have to create the higher order construct. How to create? Just delete these path here and then create a one this latent variable. Just select latent variable and drag it here and press the enter button here. So now here you can change the HOC, and so now our latent variable has been created, and but it is in the pink color. The problem is that this latent variable is not connected with the other latent variable. So now we have to connect this one, connect, and then connect, and then connect it. But again, you're looking here, still it is in the pink color. Why orange color? Why the problem is that? Okay, the problem is the latent variable has no indicator. So we have to assign the indicator to this HOC. As if you in the mathematical lecture, I told you that we have to assign the indicators to the higher order construct. So now we have added the higher order construct. So still you are looking, it is in the pink color. The reason is that we have not assigned the indicator. So now we have to assign indicator. As you select the from 1 to 5 all indicators you are looking here, correspondingly there is also selection here. So now what? Select and drag and leave your mouse here. Now these have been assigned to this one. Then again in the quality, select all these one and then drag and assign to this one. So now both indicators of the loyalty and quality have been assigned to this one. Now it's better. Now what data we have to save this one and then come here and then hide indicators in order to avoid any repetition of all these things. So now here the repeated indicator approach has been applied so far. So now what we have done, that the indicators of the loyalty and quality have which are already assigned to the loyalty income, they're the same we have assigned to the HOC. So now that's why we call is a repeated indicator approach. So now we're applying the bootstrapping. So bootstrapping. So now that has been applied. So now you're looking again, this our R square is 1 and our direct effect is insignificant and not available. So that's why what we have to, that means our these effect are, these are significant, these ones are significant, but these two issues are there. So here it is recommended that these two issues are appearing because of the repeated indicator approach. So now how to solve this problem? In order to solve this problem, data we have the like the repeated extended indicator approach. That means we have to extend our, how we can extend our this approach, that we have to put the direct path. Okay, and now bootstrapping is there, and then another direct path here. So now again the directly bootstrapping techniques is applied, and then just press here in order to, as we can understand the all the things. So now here you're looking at the two extra means a path we have assigned. The first path is the satisfaction to loyalty and HOC. That means we want to check the indirect effect of the satisfaction on the HOC through the loyalty, and another one is the satisfaction's impact on the HOC through the quality. So these two path we additionally we have assigned. So now that's why it is called the repeated extended indicator approach. So now again we are applying now all our we are going into the report. So here in our report you're looking here the specific indirect effect. The good thing of the software is it's not only giving you the direct effect. So now these are the direct effect, it is also indirect effect, sorry, it is also giving you the specific indirect effect. So in specific indirect effects what we have to, so now the first effect is the satisfaction quality. So satisfaction quality to HOC, it's a 0.23. And another effect is the there is an extent in which we we have at least assigned a new path over there. Another path was satisfaction loyalty. This is satisfaction loyalty to HOC. So now these are two indirect, specific indirect effect. So 0.23 and the 0.30. If we add, now if we talk about the total effect, because it was emphasized that if the direct effect is significant, then we have to consider the total effect. So if we talk about the total effect is a combination of the direct effect and the indirect effect. So now indirect effect is, there are the two indirect effects are there, 0.23 and the 0.30. If we add these two, it will become the 0.53. So and our direct effect is 0. So now actually our indirect effects are our total effects. So now our total effect is a 0.53. So if we take this is our total effect, then you're looking here a satisfaction to the HOC. So this here you're looking the 0.52. So now this is our effect actually. So now here you're looking, actually it is a 0.53, but here you're looking there it is the value is a 0.5. So because of some miscalculation, this may occur if we take this may occur, but otherwise it's okay. Like the 0.52 or 0.53, almost both are same. So now that's why we can say the total effect is a 0.52. So again, I'm repeating, total effect equal the direct effect plus the indirect effect. So indirect effect are our 0.23 and the 0.30. Now those become the 0.52, and our direct effect was 0. So that's why the actual our indirect effect was actually our direct effect. So that's why we have to report this effect in our thesis. And then thank you very much for watching this video completely. I hope this video is clear with different concepts regarding the repeated indicator approach and the extend repeater approach. So again, thank you very much for watching this video, and please comment, please subscribe my channel, please leave the comment on this one, and please refer these videos to your friends. Thank you very much.